Thank you very much. I hope you all had some insightful conversations. I would ask that we bring them to a close for now as we look to stay on schedule and resume with our next panel. Thank you all for heeding that word and quickly finding your seats. All right, while we're finding our seats, it's my pleasure to introduce our next panel, an IOE faculty panel on a vision for the future. This panel will be moderated by Dr. Brian Denton, the Stephen M. Pollock Collegiate Professor of Industrial and Operations Engineering and former chair of the department from 2018 to 2023. He will be moderating the panel, so let him take you over with the introduction of our panelists.
Oh, yeah. All right. Well, thanks for the great introduction. And it's so nice to see so many people out there, a lot that I know and some that I don't. I look forward to getting to know you. Today's a big day about, looking back on the last 70 years and all the amazing accomplishments, but we're going to take a short departure from that. And we're going to look to the future and what the future has in store for IOE in our field, industrial engineering. Niels Bohr is a famous physicist who famously said that predictions are hard, especially about the future. So I'm as excited as any of you about what we're going to hear today. It's unscripted. I do have a few questions that I'm going to be putting out there. And they know about some of them, but I'm also going to try to throw a curveball or two in. And we'll have some Q&A at the end, so please think about some inspiring, challenging questions for our panelists. And I also want to take care of one personal piece of business, and that is I noticed that John and Holt was introduced earlier, and I won the John and Beverly Holt Teaching Award some years ago. I have to assume it was some kind of clerical error because the competition is incredible. We have amazing instructors, across the board at the college. But it was it made my year, and I got a wonderful note congratulating me from John and Beverly Holt, and that meant a lot. And I thought, well, I'm going to get the chance to see them. So I'll thank them in person. And somehow it didn't happen. So I want to thank you for that, for me, but also for all the people that get inspired by this award. It's really maybe more important than you even know. So thank you. Maybe we'll have a round of applause for them. Okay, so now we'll get started with some fun. And rather than me introducing everybody, I'm going to have our panel introduce themselves. Everyone here is at the cutting edge of their area. So we're going to have a great opportunity to learn from them. And I've asked them to introduce themselves. And I don't think this is a curveball. I slipped it in, but maybe they didn't notice. I want them to tell us a fun fact about themselves. And these are professors, so I have to be very clear. This should not be work-related, okay? This should be something non-work related, okay? So let's start with Amy, and then we'll work our way down. Let's see.
It's on, they're all on?
There you go.
There we go. Right. How many engineers does it take to enter? Welcome, everyone. I'm Amy Cohn. This is the start of my 24th year. When Larry recruited me, I think we committed to 2. My focus is on healthcare operations, and for the last 5 years, I've had 50% of my effort as Chief Transformation Officer at Michigan Medicine. So continuing the work that many of others have done on bridging medicine and healthcare with our IOE work. And my fun fact is that 2 years ago, I stormed the field with my then 24-year-old son and 82-year-old grandfather, his grandfather, at the Ohio State game. And that this year, we're going to storm the field again.
I love it. setting the bar pretty high, Amy. A lot of people are wishing you went last, probably. Salar.
Thanks, Brian. Hi, everyone. My name is Salar Fattahi, and I joined IOE in 2020. Brian recruited me. And before that, I was with Berkeley, and I work on optimization and AI. I'm representing AI, apparently. One fun fact about me, I'm getting married next week.
Whoa. I stand corrected.
Good morning, everyone. My name is Joy Mondisa. I am an associate professor in IOE and the current director of engineering education research. I've been in that role for about 5 weeks, so cut me some slack, please. I was recruited to IOE by Mark Daskin in 2015, so I've been here for 10 years. In my subject areas, I study mentoring and professional development skills in STEM higher education, as well as continuous improvement in operations. And my fun fact is that I love to dance and I love to take dance classes. I'm from Chicago, so when I moved to Detroit, I went from doing Chicago stepping classes to taking urban ballroom dance classes.
Wow.
Hi, I'm Uday Shanbhag. I'm completing my second year. I've been in the academic community since 2006, so I'm right around my 19th year. I work in optimization and games with a strong interest in energy and power systems. Fun fact, I'd have thought the hairstyle was a fun fact, but it's not really. So here's a fun fact, right? So, last week with Salar, Albert, and Rad, I joined the IOE soccer team, and I was 3 times the age of the kids there. But that's not the fun fact. The fun fact was there was this guy who came around and asked me before the game. He had one of those things to resuscitate people. You know the thing where you zap this guy, he literally came to me and said, "Are you going to be okay?" And he had this weird, macabre look about him, which wasn't healthy. So that's not a fun fact, it's a more macabre.
We'll take it, though. Jesse.
Hello, everyone. I'm Jessie Yang. I'm an associate professor with IOE. I joined IOE in 2016. My expertise is in human factors and ergonomics. One fun fact about me is I'm very good with kids, young kids. So my plan is after I retire from this job, I'll become a kindergarten teacher.
Wow. Okay, well, thank you all. So we'll get down to some of the questions about the future. Okay, so I think I want to start with you, Jesse. I know that you do a wide range of work, lots of things that are very exciting at the bleeding edge of technology, including robotics and many other things. What are some of the most important, exciting things that you see on the horizon? 5, 10 years, not tomorrow or the next day, but what do you see that's most exciting to you?
Thank you, Brian. One of the most exciting things I see is human-machine integration. So it also occurs along with the shift from Industry 4.0 to Industry 5.0. So Industry 4.0 has been emphasizing on digitalization, automation, and integration of cyber-physical systems. But as we move on to Industry 5.0, the focus has gone beyond that, not only about machines. So we want to design systems where the humans and machines, or the humans and AI algorithms, will collaborate in a more meaningful, trustworthy, and collaborate adaptive ways. And also, I believe IOE or industry engineering is uniquely positioned to lead this shift. So we are trained not only to optimize machines, we want to design social technical systems. We want to optimize the integrated human-machine system. So to me, that's the next big thing.
Yeah, very exciting. Others, chime in, please. What are you most excited about? It's a very introverted group we have.
So maybe I'll jump in. So I think one of the things that I'm excited about is I think as research advances, I think the requirements that we're introducing on our models has never been more, right? So we 30 or 40 years ago, when we taught linear programming, we would expose or make students endure the diet model, right? The diet problem. And now we've moved past that, right? So we're looking at problems that are afflicted by hosts of challenges, hierarchy, uncertainty, risk. And I think what I'm excited about is, as industrial engineers, we have the ability to not just model, but to resolve these models through algorithms. And so the hope is that we can actually use these models effectively to improve decision-making, whether it's in Disney, Google, because I think that's the big jump, right? We have models and we have algorithms, but we have to be able to kind of articulate these questions and be able to extricate value.
Thank you, Uday. Others? What about AI? Putting a little pressure on Salar here.
I can see a few things about how IE, I think, could help with AI, and it basically echoes what Uday and Jesse said. I think us as IE experts, we don't like black box models. We like to understand what's going inside our prediction models, our decision-making models. And that's very important, especially when it comes to system-level decisions, for example, in healthcare, in infrastructures. I think knowing why we are making decisions is as important as the decision itself. And that's something that, I think differentiates IE from, say, like a CS major, because we do care about the reasoning behind our decisions rather than only prediction or maximizing the accuracy or focusing on one specific criteria.
Yeah, great. Any other comments? Okay, I love that you mentioned AI in IOE and how it differs from computer science. Of course, we have an amazing computer science department doing a lot of work in that area, but actually this is a topic that permeates all of the areas of engineering, and including IOE. And thank you for the leadership of some of these folks on making that happen. So I want to change gears a little bit and talk about some of the societal challenges that are, on the horizon. Okay, and you can choose what that horizon is: 5 years, 10 years, 20 years, 100 years. But what are those societal challenges that you think that industrial engineers are going to be uniquely equipped to address? Maybe we'll start with you, Uday. And
I think in the previous panel, there was a discussion about how industrial engineers, IOE students, are well equipped to deal with the myriad challenges across a host of applications. And I think keeping that in mind, I would see that the key societal challenges that are before us pertain to security, right? So food insecurity, or other food security, climate security, energy security in terms of being able to get consistent, reliable, robust access to energy. And I think all of these, in some sense, are compelling, enduring challenges. And I don't think that they're easily resolved.
Yeah. Other comments? Yeah, Amy, please.
Yeah, I have been thinking a lot about our aging population and thinking about IOE and our systems focus. And, in some ways, the five of us do very different things. And yet one of the things that I focus a lot on, I think a lot about, is how interconnected things are. And so we can talk about healthcare issues, and in particular, as we see the population both living longer and that the percentage is going to be older. But it's not just about healthcare, it's how do I get to the doctor's appointment? It's how do I understand the technology that's being used in the doctor's office? It's how do I avoid going to the doctor's office in the first place? It's can I continue to live in my home? Can I continue to engage in an active and a vibrant life? And so when I think about, it might be technology, it might be exoskeletons, it might be mechanisms to link us and the resources that we need. But I think that idea of not solving a task, but starting with the vision of what does it mean for our aging population to continue to live well, and how do all of those pieces connect? And then how can we link what we do together to make that a holistic approach?
Yeah, wonderful. I think we're all vested in that, and I take it that we haven't solved healthcare yet, is what you're saying.
Well, we're close.
Important for where Amy sits as Chief Transformation Officer for Michigan Medicine. So thank you for all that you do. Anybody else want to chime in there?
One big challenge I see is how we humans are going to live and work alongside AI and robotics. I believe everybody have seen those scary news. Jobs will be gone. We are going to be replaced, right? So I think technology is advancing incredibly fast. But whether and to what extent technology will help the entire human society kind of hinges on how we can integrate technology into human, right? So therefore, I feel kind of IOE or industrial engineering is well positioned to solve this integrated human-machine systems questions. Like, for example, in healthcare or in pharmacy, an AI tool can be designed to give a flag, can be designed to flag this wrong medication prescription. But if the pharmacist doesn't trust the AI tool, or if using this AI tool will significantly increase the workload of the pharmacist, they are not going to use it, right? No matter how good your AI tool is. So really, I think we need to think about how we can optimize the entire system.
Yeah, thanks for that, Jesse. Any other comments? Okay, I'm going to move us in a different direction. Something everybody has experienced in one way or another is engineering education in this room, and I'm interested to know how that's going to change. Okay, how has it changed, and what's it going to look like in the future? I know what it looked like in the past. For me, it was looking at the back of a professor who was writing on a chalkboard, and I would copy down the stuff that they wrote. And if they turned around at some point in the class, I might even ask a question, but that was considered to be sort of an annoying thing that professors had to deal with. Now, that's not at all what it looks like now, but I want to know what can we expect in the future. And I think, Joy, you're ideally situated because you're literally leading research in engineering education. So I'd like to start with you and then hear from anyone who wants to chime in.
So I'll start off by saying probably the way I view engineering education is a lot different than my colleagues, in the sense that I've looked at engineering education more in the terms of what is it as a field, what does it mean? From an engineering education perspective, we look at pedagogy as well as improving the experiences of all engineers from K through 12 to higher ed to professionals. So just thinking about how it's evolved and changed. I came out of a program at Purdue University where I earned a PhD in engineering education, and we not only took our technical engineering courses, in addition, we took courses on teaching and learning, research, and as well as implementing different types of practices. And I see what has evolved from 15 years ago when I did it to currently is as a field, we are really growing. So more people are becoming aware of the need to look at and improve engineering education and engineering education experiences. When I first started out, Purdue was the first program. Now there's several programs across the nation which specialize in various different areas from K through 12 to interdisciplinary engineering, even mentoring and professional development in terms of areas and expertise that I look at. So I guess what I see as a field, we're going to continue growing and expanding. There's been a lot of support traditionally from traditional engineering departments. Michigan is the first program to officially have embedded engineering education researchers in traditional engineering departments. We're called discipline-based education researchers. And to kind of touch on what Amy mentioned, what is happening is we're finding ways to connect within our traditional engineering departments to move the field forward in terms of improving classes, improving pedagogy. So we're working in conjunction with other engineering researchers to use the research that we're doing in the field to improve and make things better broadly. And I think that will continue to grow and change, and that's been evidenced by the growth of programs as well as supports provided by departments who integrate deeper researchers into their departments as well.
Yeah, wonderful. Other comments from any other panelists? Go for it.
So I don't even know if they had chalkboards when I was in class. I think it was more tablets that, my experience that they were kind of carving into. But what I think is really a big change, and one that I'm very excited about, is when I was a student, I learned how to solve problems. Here's the diet problem, and now we'll teach you the simplex method. And I think there is a place for that, and we do that very well. But where I see the opportunity now, and I'm looking around, I see Richard Coffey's here, Mark Van Summerin's here, and I see a lot of the folks who were in sort of the early phases of IOE in healthcare, but I think this is true in other fields as well. It's not enough to be able to solve a problem. You have to scope and figure out what the right problem is. And I think in particular, in complex systems, my emergency department's really crowded. I could build all sorts of beautiful models to figure out how much bigger to make the emergency department or how many more ER doctors to hire. But the reality is maybe we need to do a better job of vaccinating against RSV so there are fewer people coming to the emergency department, or build a training program for skilled nursing facility staff so we can discharge from the hospital faster so that we don't board in the emergency department. And I see IOE doing more and more experiential learning where students are not given a homework assignment to solve, but given a challenge to address. There's not a right answer, but that idea of teasing out what is it that we then need to apply our technical skills to. And I think that is something that has suited our students really well in terms of being able to go into an environment and say, what is the essence that needs to be addressed here?
Yeah, great. Thank you, Amy. Anyone else want to chime in?
Yeah, I think I want to talk about a slightly different facet of how IOE's programs will probably undergo change, particularly in the face of what's happening with AI. I think one of the challenges that at least some sub areas in IOE have faced is that we're in a lot of settings adjacent to machine learning and artificial intelligence. And as a consequence, some of the work that we do actually gets either subsumed or kind of pulled in within AI, when in reality it's decision making, right? It's operations research or maybe optimization, applied probability, simulation, but it gets pulled under this larger umbrella. I think it's important for our identity to be able to qualify what exactly we do, make sure that our students can distinguish what we're contributing, right? So decision making is not the same as AI, right? So if you want to solve massive integer programs, you're not going to be able to use ChatGPT for that. You're going to actually have to be able to leverage state-of-the-art solvers. And I'm curious what Salar also thinks in this light, that you have AI, which is this all-encompassing, but it also seems to kind of take credit for things that are not necessarily AI. At least that's my rather biased view. But I'm curious what Salar thinks.
I completely agree with you, Uday. And I do think, like incorporating AI into our classroom is very, very important, especially when it comes to the intersection of data science and optimization, because it's not only about getting the answer, it's more about, okay, so you have the answer, how do you explain it, how do you interpret the prediction, for example, that you get from your system. And those are the things that I think AI can help, but it's not, we cannot only rely on AI tools to really make sense of our answers and solutions. And that also goes back to what Jesse said earlier. Yeah.
Okay, thanks. And I want to follow up on that. Many people may not know that here because you graduated before this happened, but we made some fairly significant changes to our undergraduate program to incorporate more data analytics, more data-driven decision-making, machine learning, and other aspects of artificial intelligence. And so Salar was one of the people. It was a team effort, but he created the first elective course we have that involves AI and data analytics for our students. It's, I think, one of the most popular, could be the most popular. I don't keep track of all the numbers, but students seem to be enjoying it very much. What do you think our students are capable of doing now that maybe they weren't like 10 years ago or something like that? What are they coming out with? What kind of skills that some people here might like to know about?
Yeah, now that's a very good question. I do think that our field is changing very rapidly, even compared to 5 years ago. I think IE majors, we train as people who are very good at optimization and maybe stochastic processes. But today, more and more, we are incorporating AI, data analytics, and machine learning into our curriculum and in our research. But also, it is a little bit different than what again, computer science does. We always take this view of like system level and decision making at a system level perspective. And that's, I think, what IE major can bring to the table. We can sit with computer scientists. We can talk the same language, but at the same time, we can bring a new perspective, which is okay. I do care about minimizing the cost or maximizing the accuracy, but at the same time, I also care about robustness. I also care about other trade-offs. I care about fairness. And these are the things that I think IE experts can contribute to and help with. And I think that's what IE and OR, in fact, we're moving towards, and I think it will be valuable even in the future. Yeah.
Great. Yeah, so this will be one of my curveballs. Jesse, I wonder if I could cold call on you to speak a little bit to this, because you are doing a lot related to AI. I know some things like human-robot teams, really some exciting things, and from a different perspective. Do you have anything to lend to that? What are our students going to be able to do maybe in the future that they skills they didn't come away with to begin with?
Yeah, at first I would like to say, I think if you compare IOE against other IE programs in the nation, I think first we are doing very good in terms of kind of destroy the boundary between OR and human factors. In many of the IE programs, they are rather siloed, two different areas of research. But in IOE, we are trying our best to kind of encourage collaboration in those two sides. And I think for like future IE students, I think in order to enable them to be a solution, I think they really need to blend all those data analytics and modeling techniques with human factors knowledge, right? So not only about how to solve the equation, but also understanding how humans perceive stimuli, how they make judgment, how their sensory motor systems work. And I think for IOE, I would say we are at the frontier right now among all the IE programs to do that.
Yeah, terrific. Thanks for your perspective, Jesse. Anybody else want to chime in on that? Okay. Well, I want to take things a little more industry specific, I guess I would say, or application specific. So Julie Ivey earlier today mentioned some of the strategic directions that we have in the department. I think of them as falling into tools and applications. And of course, the tools drive a lot of the decision making in the application areas. And areas of focus, those have changed over the years. To some of you, it was mainly manufacturing systems when you came here. Still obviously very important, and we're still doing work in that area. But some of the primary pillars in terms of applications are operations management. Okay, that hasn't changed a whole lot. The nature of it has changed, but we've been leading in that area for a long time. Other areas are health and human safety, transportation and mobility, and energy and sustainability. These are some of the areas that we have identified as areas we want to, be excellent in, both from a research perspective and educating students. So I want to hear from each of you from your perspective, maybe starting with you, Amy, if that's okay, on healthcare. What's one example that you're sort of most excited about?
There are a lot, but I think one of the things that I'm most excited about is something that's perhaps getting a little bit less attention when we think about applications in healthcare, and that's primary care, and in particular preventative care. So our health system is designed that a lot of the resources go into surgery, inpatient care, cancer treatment, all of which are very important. But where we tend to really struggle is the resources and the infrastructure that we need for primary care. And in particular, I think about how reactive healthcare is. You get hurt, you go to the doctors. You get sick, you go to the doctors. And what does it take to focus on wellness instead? What does it mean to focus on not developing the illness in the first place, predicting it early, and so on? And so that to me is an incredibly exciting opportunity, first of all, for AI. And I think somebody, maybe Jesse, mentioned the word trust. And I think that's a place that we could play a really important role. Is primary care is an environment where people go into that field, not because it's the most lucrative, not because it's the most glamorous, but because they don't want to treat an episodic illness or injury. They want to have a relationship caring for a patient. We don't have enough resources for all of the work that they want to do in not just treating the strep throat or the broken bone, but the making sure you're getting the resources you need for healthy diet, for smoking cessation, for exercise, for your mental health. And so how do we bring in all of the different resources that can allow us, again, as our population ages in particular, to be able to help keep people healthier, and do that in a way that actually aligns with how our system is designed and how it's going to evolve over time. And so I think every one of us, again, has things to contribute, and we have to do it holistically.
Yeah, it's so human-centered. And one thing that resonates with me that you said, Amy, is that it's so connected to Jesse's point about, looking at problems at the intersection of human system integration, operations research, many different kinds of aspects. These are difficult problems, and people are at the very center of that. So, thank you for your perspective. Shall we keep going down the line here?
Yeah, so one area that I think could be, and it is evolving over time and it's exciting, especially for me, is, for example, in the area of operations management, recommendation systems. I think that's something that I think we see. It's basically a real-time matching of demand and supply. And there are a lot of examples of that, for example, in recommending in streaming platforms, you recommend new videos, new content to different customers. In retail markets, you just recommend new products to customers. And even in healthcare, you recommend you want to recommend the best treatment options to the patients. And I think it is becoming more and more personalized, and that's one thing that I think is going to be more and more relevant to what we do in IE. But at the same time, they could be drastically different because, for example, in healthcare, the cost of making a mistake is probably significantly higher than, say, like a streaming platform. So there are a lot of similarities in all of these recommendation systems in terms of the main goal, but at the same time, they have some unique difficulties that we need to address. And I think it's both exciting and great opportunity for us to have meaningful contribution in that domain.
Yeah, wonderful. I think that what I like about that is it touches everybody. If anyone has ordered something online or from Amazon or whatever, there's a lot that's happening behind the scenes, and Salar is helping our students, learn about that and develop some of those cutting edge skills. So very, very exciting. Joy, you're not working necessarily on a particular application area. You kind of cross the whole spectrum, but so is there anything you would like to comment on related to that?
Actually, yes.
Great.
As you mentioned when you were first speaking about this topic, the areas have shifted a bit. We used to primarily, if you were here a while ago, be focused on manufacturing systems. I want to reassure you we are still focused on manufacturing systems as well as operations. And so when I think about what I'm most excited about is looking at operations management in terms of helping our students to learn how to think critically and to implement continuous improvement principles in learning organizations. So what we've been working towards, especially I would say the last couple of years, is looking at ways to continue to help our students have experiential learning with different corporations and organizations, and what does it look like to implement continuous improvement in different types of organizations and contexts and settings. And we're looking forward to continuing to expand that, as well as thinking about what does it look like to take what we're learning in the classrooms and teaching our students and actually do that in applied and I would say real world applications with industry sponsors. So definitely I'm excited to say we're still focusing on operations from several different views and venues and looking at how we can continue to evaluate manufacturing systems, supply chains, and continuous learning.
Fantastic. And I want to come back to the experiential learning aspect of things in a few moments, so we'll put a pin in that. So Uday, you're one of the leading experts in our field. I'm trying to embarrass him here, in energy, but that is true. I'm not making that up. So I'd love to hear your perspective on the work that's going on in energy. What's exciting you most?
Yes, leading expert is a bit, that's an egregious exaggeration, but I'll let that pass.
I told you it would be embarrassing to him.
But I think on the energy side, particularly the power systems side, I think the transition to a truly sustainable power grid is something that is both exciting, but is also causing a fair amount of trepidation, if you will. So for those of you who are familiar with this, one of the big success stories of optimization in terms of its integration with power systems was emerged from the fact that when you're actually doing pricing of electricity at the wholesale level, these grid operators are actually solving integer programs. They're actually using state-of-the-art solvers. The research for this has been carried out in departments like this, right? In IEOR departments. And so a lot of that is linear programming, integer programming, and the consequence of that is deciding which generation units get switched on, which ones get switched off, and how much do we run each unit for. Okay, and this is run many times an hour on networks that might be of hundreds of thousands of nodes. And these are in control areas like PJM, which is on the East Coast. You have the New England Power Pool, which is now called ISO New England. You have stuff happening in Texas, in California, and so on. But now in the future, when you start integrating renewables, a lot of those algorithms cannot be expected to sustain. And the reason is that you have to incorporate nonlinearities, right? As Salar would know, you have to deal with what is called reactive power, right? So these nonlinearities lead to far harder problems. And these problems have to be solved. They can't be AI'd out, if you will. They have to be solved using optimization solvers. And the current solvers cannot process such problems. Right? So you need schemes that can deal with the uncertainty that is nascent when you try and integrate renewables. You need algorithms that can deal with the nonlinearities and the dynamics that emerge from the presence of renewables in your power grid. But it's crucial, because if you actually have to make a transition that is sustainable and stable, you need to be able to solve these in a scalable fashion. It's not easily achieved. But I'm excited about it because I think we have a large role to play. I think the problems that are emerging are challenging, onerous, and compelling. But I think we have a significant voice in this.
And important, I would say. Everybody wants their lights on. So thank you for that update on energy. And then, Jesse, could I ask you to speak to mobility and transportation?
Yeah, sure. So I think there are many exciting research lines at different scales in transportation. If you look at the macro scale, there are some research along how to use kind of data-driven optimization scales to reduce congestion, improve efficiency in air traffic management or in the management of the traffic lights, right? Those are at the macro scale. And you can imagine the kind of the level of uncertainty involved in that type of optimization. And also at the micro scale, there are some exciting research examining how humans, including drivers, pedestrians, cyclists, interact with autonomous vehicles. And how can we design autonomous vehicles that makes people feel safe and comfortable interacting with them and share the road. Yeah, so exciting research at many, many different scales.
Great, thank you. Thank you very much, Jesse. I want to come back to that point about experiential learning. So, anybody who's come through IOE or any engineering discipline has probably gone through a senior design project, a capstone project, where you get some experience in the real world with some guidelines or guardrails around you. But there's a lot of other things that are happening in the department as well when it comes to that. And so I'd like to start with Joy and then Amy, if I could, because I know that both of you are doing a lot in that area, and then anybody else can chime in after that.
So yes, as Brian said, there's a ton of experiential learning going on in our classes, especially in IOE. Some of the things I wanted to talk about specifically were our Engineering 100 courses. We have a continuous improvement and operations course in which students get to work with typically an industry sponsor, hopefully, most likely, as well as using CI principles in like an actual real world application. When I taught this course, we actually, at the suggestion of Larry Seaford, we worked with the coffee shop Mujo's, and we actually helped to make their processes a lot more efficient. Students got to engage and learn quite a bit. There's also other Engineering 100 courses that I'll briefly touch on, like Yavuz Bozier's Engineering 100, where he partnered with Domino's Pizza, and our students got to work on supply chain management issues. And most recently, I became aware of Amy's Engineering 100 course. I was chatting one day after teaching with one of your colleagues, and he was telling me a little bit about how students are working in healthcare and different issues, but I'll let you talk a little bit about that. In addition, at the graduate level, we have several courses that reinforce experiential learning, such as IOE 524. That's Ray Muscat's course. It's a master's practicum. I've heard rave reviews from students about this course because it allows the master students to engage and work with an industry sponsor who's also their mentor, as well as being mentored by Ray as well, where they work on a specific designated project, so they're getting real world experience and exposure, as well as learning and applying some of the skills that they're getting from the class. And another course where we leverage experiential learning is my IOE 525 Lean Principles and Scientific Thinking and Organizations course, which is actually an evolution of the course that was taught by Jeff Leiker. And in this course, we teach students continuous improvement in scientific thinking methods. We work directly with several Ann Arbor businesses, such as Zingerman's Mail Order, Zingerman's Deli. We used to work with Toyota as well as Subaru as well. And the entire semester, students are engaging with the individuals' industry sponsors, as well as myself, and practicing and solving challenges and skills with the actual lessons that they're being taught in class, and as well as learning scientific thinking methods. The other thing I did want to briefly note is the last couple of years, we have been working on advancing an initiative. Right now, it's being called the Continuous Improvement in Learning Organizations Initiative. And we have the support of our department chair, as well as a task force that includes Dave Ostreicher, Larry Seifert, Ray Muscat, and Deborah Leventrosser. And over the past couple of years, we've hosted events with industry sponsors, as well as IOE faculty and staff, to really capture what they're interested in having our students know when they come out of our program. What experiences do they want them to have as they're learning in our program? We've done that the last 2 years. And currently, fingers crossed, I left out Yavuz. He's been working with us. We're trying to prepare we've prepared a graduate certificate proposal for a continuous improvement in learning organizations grad certificate, because in speaking with industry sponsors, we realized that they really wanted to see what courses and experiences students were having, how they were being trained, and how we could capture that in the certificate. That's currently up for review. We're hoping to have that go through in the next couple of, let me not say next couple of years, maybe in the next year. And from that, we're hoping to develop a lab component where we'll be engaging in working with industry sponsors and partners and really connecting them with our students to help continue continuous improvement learning and helping to prepare students to go out and work in these organizations.
Yeah, outstanding. Thank you for some of that insight into some of these things that are also happening with the master's program, for example, and shout out to Ray and Amy. So in one of your hats, I don't know how many hats you wear, but you wear a lot, I think, but one of your big hats is to direct the Center for Engineering, CHEPS, as everybody knows it. There's an experiential learning component that's happening there, where you have an army of students that are working on important problems. Could you maybe give a little bit of insight into that from your perspective?
Yeah, absolutely. And Joy teed it up very nicely, talking about preparing students to go out and work. And one of the things that we observed with healthcare is that it's different than the work I've done with automotives or manufacturing or transportation or telecom. Then Dean Munson and Dean Woolliscroft about 15 years ago said, you know, when you graduate an IOE student and send them to Ford, everyone knows what to do next. And we're not doing that in healthcare. And so I think Jim Bajam may be here with us somewhere today. And they brought in Jim with the goal of creating this Center for Healthcare Engineering and Patient Safety, with the idea being that our output, our product, would be engineering students who were prepared to go into a healthcare setting and from day one really hit the ground and make contributions. And what evolved over the next 13 or 14 years was really not only the building of that, but we brought in some public health students and some nursing students and some pre-med students, figuring that they would help support the engineering students. And what we've discovered is that many of those students actually started thinking like engineers. I have a nursing student who's currently talking to me about how they might become an IOE master's student as part of their continued training. And I think another good example, we may have Billy Pozell here somewhere. And Billy is someone who took IOE 310 with me as an undergrad and was recruited to work on healthcare problems as sort of a part-time job at CHEPS while he was an undergrad, and then decided to stay on for a master's. And then we managed to convince him to stay on working, mentoring students, and has just become our assistant director. And we have about 50 students now, ranging from freshmen all the way through postdocs, from industrial engineering as well as computer science, BME, public health, nursing, economics, and so on. But they are working on real problems. For the first time in over 100 years, the governing board of obstetrics and gynecology has changed their protocol on prenatal care, and we have students who are part of that. When the recent hurricane took out some major facilities that manufactured IV fluids, and hospitals all over the country were trying to figure out, were they canceling surgeries? Were they, unable to provide care? I had students who gave up their fall break weekend to build models and simulations and dashboards to be able to understand what the ramifications were going to be. And we've had students who were pre-meds in engineering decide that they were actually going to stay in engineering because what they really wanted was not to do medicine, but to help people be well. And so it's just been incredibly rewarding to watch this community grow. And I think we've got some of our alums here as well, folks who are now working in the healthcare system. Nick, I'm going to embarrass you if I can find you, who are coming back to advise and mentor and support and in many cases recruit our students. So, when you think about medical training, I'll end with this. There's this notion of residency. So you take your classes as a med student, and then you start going into clinical environments. And then you become a resident, and you are caring for patients while you are continuing your training. And if you ask the medical profession, is residency about providing care for patients, or is it about training? They can't answer that question because they are so completely coupled together. And what we have experienced is, does CHEPS train students, or does it solve problems in our healthcare system? We can't have one without the other. And so I'm just really grateful to the department and to the college for building this structure and for what we've seen it do in terms of our students and their development.
Yeah, that's wonderful. So that was a lot of examples of the ways we rely on industry interaction for this experiential learning. And I also want to give a shout out to our amazing senior design instructors who don't happen to be up here, but they're constantly doing an amazing job creating experiences. I think it's fair to say that we're always looking for new organizations to work with. So if you feel like you'd like to get involved, feel free to talk to any of the folks here, Ray Muscat, who else do I see? Prakash Sati, and probably many others who will be happy to help you figure out how to do that. So yeah, I'm watching the clock here. I guess one thing I want to do actually to point out also is that we have something coming down the pipeline. I don't think it's been officially announced anywhere, so keep it hush hush. It's very confidential. But we're working on a new master's of engineering that would focus on data, decision analytics, and other related topics. It'll be available online and in person. That's the intention. And the online portion is going to be designed so that people working in industry can, simultaneously complete a master's degree. So stay tuned for that if that has caught your attention, or if you're interested in that. More to come on that. But in the interest of time, I want to make sure that we have some time for the audience to ideally throw some really tough curveballs to these panelists with any questions you have about, the future of our field, anything you heard today. So I believe that somewhere we have some microphones. All right, all set in the back. So please jump in with any questions you have. And I see a hand up right here. So thank you. The microphone's on the way.
Good. My question really is to the whole panel regarding the education of the students. I was particularly interested in Amy's comment about, are we even asking the right question? Because that is the challenge with a lot of these things is, are we asking the right question? But my point is the following. I worked my whole career in healthcare, as many of you might know. And we used to do these things like we'd do simulations and we'd have this big stack of printouts, right? And we'd go to the leadership and say, hey, it says here to do this. Nothing happened, okay? When we switched to a visible simulation model, and there's several of them, and we would show it, and like we did it in an emergency room, and they would watch the patients come in, and they would watch the nurse go in the room and so forth, and then it says, okay, we need to change our staffing by this much and change our process. They actually did it, okay? And one of the challenges with operations research stuff is you develop this elegant model understood by the engineers. And my question is, how are we teaching students to translate this stuff, to illustrate this stuff in a manner that there actually is a change in operations rather than just a model that shows you should change?
Great question. Everybody's raring to dive in. That was a good one. I like that from a curveball perspective. All right, so who wants to tackle that? One thing I'll say, just to give the folks here some time to respond, is, so first of all, that's an excellent question, and we're constantly working on that. One of the things that, I don't know if it's unique to University of Michigan, but it's not very common to have a very strong technical communications group that we work with, and that starts in year one. Okay, so sometimes these things get saved until the end, the capstone project, but that's far too late. So they get exposure to this in year one, learning how to communicate technical results, not to themselves, not to necessarily other engineers, but to smart people who maybe don't have an engineering mindset. And then there's some things that follow them, and then when they get to senior design, that's course that's co-taught with somebody from technical communications. This is an amazing group, and we are very lucky to have that. I could rattle off a bunch of great universities, all not as good as IOE and University of Michigan, that don't have that, but I'm not going to do that. I'm going to resist that competitive urge, but that's one of the nice things that we have here for our students. But help me out here. What else?
So I have struggled with that same challenge as you know, and again, I think healthcare is one of those places where perhaps it's the most difficult. And I think one of the key things that we need to focus on training our students and frankly ourselves is not just about how they speak to our collaborators or the end users, but how they listen. Right, that the nuance of the problem is often something that we overlook and we undervalue. And so I think it's about building trust, as we talked about. It's about understanding the transition from what is research to what is practice. And I think providing opportunities and encouragement for our students to be really deeply listening to the people whose problems they're solving, and to be able to recognize that what doesn't sound like something very important may actually be a linchpin in terms of whether your results are successful. And I'm going to give two different examples of that. One is on the technical side, and I think, frankly, this is a place where we are different when it comes to things like AI from computer scientists, is understanding the domain in which that work will be applied. So we might build a beautiful, sophisticated scheduling algorithm for operating rooms and have no idea that our nurses are unionized. And we can say, that's a detail, I'm going to solve the hard part, and then that can be dealt with in implementation. Except the nurses' union contract stipulates a type of break schedule that makes your model nonlinear, right? And it's not an implementation detail, it is the essence of the research. And if you are not listening to understand that your clinical partners are thinking about their nurses' union. And then the second piece of that is, it doesn't matter how good the results are, and it doesn't matter how well you can explain those results if they don't resonate with the end user's values and their incentives and their motivations. And so again, I think that listening piece of, don't just give me the homework assignment, right? Tell me about what you do and why you do it and what happens around you and what is problematic. And if you can develop that sort of humble inquiry, that empathetic listening, I think it also creates relationships that make people more comfortable saying, you know, an orthopedic surgeon doesn't necessarily want to say to a sophomore, I don't know what that word is that you just used. And that's where the barriers come down.
Yeah, and something, thank you very much, Amy. I sense that you're ready to jump in, Salar. And one thing I wanted to point out is your point about black boxes, people not liking black boxes really resonated with me. Like, people don't like stuff they don't understand, especially if it's potentially going to have a big impact on them. So what's your perspective on any of this?
Actually, I echo everything Amy said. And I just want to add my own experience with dealing with this. How do we teach or educate our students in a way that it would be useful when they go into industry? So, as Brian said, the first time I designed this new course on data analytics, I was struggling to decide even on the material of the course, because I mean, one course on AI and data science, you can't really teach everything. You have to pick and choose. And the first time I taught it, I was looking at different courses at different universities to try to come up with a list of topics that I would like to cover. And then later on, I realized that the best way to design the curriculum or the syllabus for a course, at least for data science, was for me to invite people from industry to come and give talks, not about new methods, but about the challenges they face in their, let's say, tech company. And based on that, I think it was a good experience for our students, but it was also very educational for me to decide on the topics that I want to teach in my course that could be relevant to our students once they graduate. So I think this constant partnership with industry and having the flexibility to change the course as we move forward, as the industry also changes, especially in data science, I think it's very, very important to remain flexible and be willing to change the material that we teach the students while getting feedback from the industry. And I think the best way for me to do that was to invite people from different startups, tech companies, Lyft, Uber, to have this, to bring this insight to the class.
Wonderful, I love it. Other questions? Oh, we got one over here. And I apologize, it's hard for me to see the, okay, we have a microphone over here, so we'll go here and then here.
Here?
Yeah.
Okay, thank you. What do you see as both the biggest challenges over the next 5 to 10 years for IE, either as our department or as a discipline? And I guess maybe corollary, what are you most fearful of?
That is a good curveball question. Go for it.
I can take a partial crack at it. It's a tough question. So I think one thing that I don't want to say fearful. I do think that we have to be able to delineate and emphasize what we do versus, say, what CS does. Right? And I think that's becoming increasingly a challenge, particularly because of the adjacency of some of their work. So I think, and I'm going to speak a little more narrowly in terms of our discipline in operations research. We have to emphasize how we bring value. We have to show, and we have to endow students with the ability to model intricate settings, try to kind of make the black box gray, right? And add value from that standpoint. Because one thing that you do not see as consistently in other disciplines is the ability to bring to bear the power of expansive high fidelity modeling and the associated algorithms. Right, so focusing on decision making, incorporating the varied challenges. I think we have to do that. We have to be able to demonstrate that adds value, and we have to distinguish it from this all-encompassing umbrella of what they call AI, because a lot of it is decision making, but they'll call it, And so I think that's important for us as a discipline to be able to distinguish. But
wonderful. And I think we could have lots of discussion on that question, but I want to take one more question. We're just about out of time, but we'll take it from this gentleman here.
Yeah, I'm dating myself somewhat, but I remember my first job as an industrial engineer was in Kaiser Aluminum, pounding aluminum blocks into parts, dirty plant. And you mentioned manufacturing, that you still are concerned about it, but it seems to be it's getting kind of lost with all the other fancy things like AI and data analytics. But where do we stand with that in terms of a department? And are the students still interested or willing to do that kind of more core manufacturing type work?
Yeah, let me turn to my panelists here. I'm happy to, yeah, please, Joy.
I'll take that, since I don't have Yavuz here to assist me. But I would say definitely, yes, students are still interested and involved in experiential learning as well as classroom learning related to manufacturing, primarily with the courses that I teach and that I've also talked to my colleagues about. There's a lot of interest around, it's not necessarily a course, but interest around consulting, manufacturing and systems. So when I think about where our students are going out and getting jobs, my first job was as a linear mechanical engineer, manufacturing linear systems. Some of the students I speak with who graduate, they're doing similar work, but they may be doing it in a different capacity. So they're still taking manufacturing classes, they're still taking supply chain management, taking continuous improvement, but there may be some, I think, slight shifts in the input jobs that they're going into. A lot of my students are at KPMG, Blue Cross Blue Shield, but there are also students who are in logistics and warehousing, depending on their specific area of interest. So I would say there's definitely still an interest curriculum around that, and we're also still trying to grow that more and expand that to keep students engaged and enacted. And I'll also put out a plug for anyone who's interested from industry and working with students. Deborah Leventrosser, myself, and Ray would love to speak with you.
Yeah, wonderful. Thank you, Joy. And I'll also add there are a number of faculty members that are really working at the cutting edge in manufacturing, smart manufacturing, using computer vision, for example, to identify defects, without requiring human intervention. There's just an enormous number of exciting opportunities. So I'm glad that you mentioned that, because it's very important and it is something our students care about. So we're out of time. Nobody started any music, but I have a little timer here that tells me that it might be getting close to lunchtime. So I want to thank you all. I want to thank our panelists. First of all, let's give them a big round of applause. And I want to thank you all for being here. And maybe we'll get together for the 80th in 10 years and we can grade the panelists on their predictions for the future. But with that, thank you all, and let's have some lunch.